So the what statistics is coming from a what statista, if I'm not wrong, and it talks about how to create inference about a big group from a small set of numbers. So why that is important? Because oftentimes it is difficult to get an idea about the whole group. Let's say if you are trying to create an idea that what is the average income of India's population. So ideal way to do it is that find out the income of every person in India and then add it up and then subtract it with the number of persons that you have collected. However, that itself keeps changing because every day the number of Indians change, because some Indians are born and some Indians die. So the whole operation will not happen in one day, and it's impossible to collect all those data in one day. And if things keeps on changing, then it's probably impossible to find out the average income of the people. Now, then the question comes up is that then how will I do it? So that is where the concepts of, I would say, this statistics comes in. So what is the job of statistics is it ensures that if you can get an idea about the overall income of the person, average income of Indians from a small set of data. So what is that small set of data called? That is called a sample. So we get an idea about the population from a sample. Population is all the people, all the observations that you should consider when you are trying to do certain activity. Sample is a representation of that group. A smaller representation of that group is called sample. So here in this particular session, we will start with that. Now, when I talk about population, we try to get populations an idea about the population using something called central tendency. So what is central tendency? Central tendency is basically the core tendency. The central means core, the, I would say, basic tendency of the group. Tendency can be also be termed as, let's say, uh, basic nature of the group or the core identity of the group. All of these things can be termed as central tendency. So if I try to find out the core nature of the group, what we generally try to do, let's say, if I ask you that, how do you describe a particular class? For example, Gaurav, if I ask you, Gaurav Sharma, from the participants.
Yes, sir.
So, what do you work, Gaurav Sharma?
Okay, I work with Hero FinCorp.
And in what role?
So I'm in model validation team.
Okay, so in this model validation team, if I ask you, describe your group of people who work in model validation team in Hero FinCorp, how will you describe them?
So I would say it's a team of analysts, data analysts.
Team of data analysts. Anything else?
So other than this, I can also.
What about the gender?
Okay, so most of them are gents.
What is the age group?
Age group is between 25 to 40.
What is the native domicile? South India, North India types?
So it's a mix, you can say.
Still, can you describe the mixture?
Okay, maybe you can say Central India.
Central India, I would not, I cannot take it. They're not from Central India. Probably very less amount of people will be. Central India
Okay,
means
maybe,
what? MP,
yeah,
right?
East India.
Okay, mostly from East India there.
Yes.
Okay, I don't. Okay, that also itself is a. Anyway, so are you from Calcutta by any chance?
No.
Means are you located in Calcutta by any chance?
No.
So then I don't know how you are saying mostly from East India.
Okay,
Anyways,
so many of them, the native place for them is Kolkata and Bihar.
okay. Now, can you tell me a little bit about their income?
Um,
Broadly, imaginary, even imaginary will do. I'm not asking you how much Eurofin Corp is paying. Let's say imaginary, you can tell me.
so could say, I mean, range between 10 to 30.
Okay, so range between 10 to 30 lakhs. Marital status,
Mostly single.
mostly single. Okay, I will stop here. So you see, what this is how he is describing his group, and what is the description that is coming up? Let's talk about that a little bit. So most of them are men, mostly single, most from East India. We're using a term called most, and the variable is the gender, the marital status, the domicile. These are the variables. So basically, this is called mode. This particular term is called mode. We are describing it using mode in what situation? When the variable is not a numeric variable. In such kind of a situation, we are using something called a mode. But if it is a numeric variable, for example, age or income, what he is basically giving is a range. Between 25 to 40 is also range, between 10 to 30 is also range. But if I ask him the average, let's say, he will be talking about the median or the mean. So I will talk about the range later, a little bit later. But this is what we are getting. So these are how we describe a group, and that's called the central tendency. Just 1 minute. Let me scroll down. So what is then the central tendency is? A central tendency has mean, median, and mode. For categorical data, you will use this. For numeric data, you will use mean and median. And in what kind of cases median works better than mean when you're trying to do the central tendency? Mean means the average, basically summation of, we note it down by mu, and summation of xi capital N, where capital N is the number of observation and xi are the individual observations. And median, on the other hand, is the middle number. Middle number when the data is sorted. That means either smallest to largest or largest to smallest, you sorted the data set, and the middle number is your this particular thing, so which is the mean. Now we use categorical data and numeric data. So to understand a little bit better, we have we have to know what is categorical data and what is numeric data. So before I jump in to discuss about mean and median, I will quickly give a idea about what is categorical data and what is numeric data. So data is of broadly two types: categorical and continuous. Categorical means they take certain values. They do not take all values within a range or infinite number of values within a range. But continuous data within a range, within the upper limit and lower limit, can take infinite number of values. Categorical data can be also of three types. One is called nominal data, one is called ordinal data, and another is called interval data. What is nominal data? A nominal data is basically the names. For example, just now the three examples that he gave: gender, then domicile, and then let's say what else? Marital status. So these are all nominal data. These are names. There is no way to define an order in it. There is no way to define that this is higher than this and this comes between these two. There's no way to define that. For example, male and female and others, let's say, you cannot define an order in it. Or your East India, West India, North India, South India, Central India, you cannot define an order in it. So that is called the domicile. So that is called nominal variables. Then comes the ordinal variables. Ordinal variables has an order, not only name, but also an order. So see, from slowly from the left side to right side as we move, we are increasing the nature of numbers in it. So numbers have names: 2.5, 3.2, 4.8. These are all different numbers, and you can identify them differently. Now they also have orders. So we are bringing in that characteristics here. We are bringing in names plus order. So how, for example, let's say in the Likert scale, high is medium is greater than low. So this is high, medium, low. This is an ordinal variable. Or let's say your your seniority level in the, we call it M1, M2, E1, E2, depending on different organizations. This kind of seniority levels are assigned. So that is a ordinal variable. Or let's say highly dissatisfied to highly satisfied to highly dissatisfied. These are all examples of ordinal variables. In interval, we bring in further more characteristics. We not only not only the groups have a name, not only the groups have an order, but the groups can also take part in a little bit of mathematical analysis. So that is where the interval variable comes in. I can find out the mean, standard deviation of these groups. For example, what? Let's say age group. So age group varies from, let's say, 0 to 20, 20 to 40, 40 to 60. This kind of, when you define, age group is a variable which is an interval variable. Similarly, let's say if I say income group, let's say, which is used in taxation. So let's say 0 to 2.5 lakhs, 2.5 to 5 lakhs, 5 to 10 lakhs. Not always it has to be in the same interval. It did not be. So that's an interval variable. What more characteristic came up? An additional characteristic that has come up, which is the ability to do mathematics with it. But continuous variable are also called as ratio scale. It has further more characteristics. What? Here, the ratio between two numbers are also defined. Till now, in age group, you could have found out the mean and standard deviation and etc. in the interval variable. But the 0 to 20 divided by 20 to 40, these two age groups ratio has no meaning. However, if you say here, let's say my income is, let's say, 10 lakhs per annum, and your income is, say, 20 lakhs per annum, you can actually say that your income is twice of my income. So this twice, which comes from this ratio, has some meaning in it. So that is called ratio scale. This is also called basic numeric variables. Now this is where mean and median will work. This is where mode will work. This is also where mode will work. we can find out mean median for interval skills. How to do it? Search in Google. It's a little bit it will probably take a little bit more time for me, and I will not spend time on it, because most of the time, most of your real life situations, you will not face this kind of situation. You will convert an interval variable to a numeric variable and do your activities rather than keeping it numeric. So we'll do that later. However, now the question comes is that, okay, I understood for numeric variables we use mean and median for central tendency, and mean means this, which is an arithmetic mean, and there are other kinds of means are also available, like geometric mean or hyper harmonic mean. I will talk about that, how they are used. But what about this median? Median is the middle number. The basic question comes, I want to ask is that which one is better? Which one will you go for and why? Anybody? Yes, Ashish.
So when the data is skewed, we'll go for median
Why?
because the average value, the mean, will be pulled towards the skewed values. Because if there is a high value, the average will be higher. Then so it will not be representative of the central tendency of the data.
But median will be the representative.
Yeah, median will be the middle number. So I think that will be
No,
valid.
why? Question is, why do you think that median will still be a representative even if the data is skewed?
Even if there is a higher value, the middle number will not change much.
Yes, that's the reason.
Yes.
Akash, anything you wanted to add? You raised your hand.
Yes, sir. When we have outlier in data, we will use median.
Okay. So, so this is the same thing that Ashish told and Akash told. The meaning is same, that when you have outliers in the data, when the data is skewed means that there is one or few observations which are very away from the major group of observations. In those kind of situations, you will go for median. So you will plot a histogram of the data, and how to plot a histogram of the data, Gaurav will show you in the next week. But you will plot a histogram of the data and you will see that how the data set is before you believe on any central tendency. So what is a histogram? Be with me. I will come to you and show. Now, I will go ahead a little bit quickly and I will talk about something called a geometric mean. Because we are doing mean, let's quickly discuss what is geometric mean. So geometric mean is, let's say if you have x1, x2 up to xn in number of observations, the geometric mean is nothing but the product of x1, x2, x3 up to xn to the power 1 by n. Now the question is, okay, this is geometric mean. Where will I use it? What is the usage of this geometric mean? Anybody can suggest in the class? What did you use in your life a geometric mean? Nobody? Okay, let's give an example. So sometimes I get people who are LIC agents. Okay. And they come to me and they say, sir, why don't you invest in a mutual fund or this fund or that fund? And they tell me that they show me the returns, that how much returns this will give you in the 5-year platform or something like that. So they show you a 5-year score, or let's say something like last 1 year score or last 1 year previous year, something like that. So let's say you invest on the first year some 100 rupees in some particular and this guy says that, sir, in the last 3 years this has happened, and if you just assume that this is something that will again get repeated, see, first year you get around 10% returns, next year you get a little bit of loss because of recession and etc., which is, let's say, minus 3%, and next year you got, let's say, around 13% return. So, sir, in total, it is okay. It's not divisible by 3. Just 1 minute. Let me do a little bit change. Let's make it 10 or 11. Okay, let's make it 11. So this was the return, let's say. So they say that, sir, this is our the 3 years return. So average return is basically 11 minus 3 plus 13 by 3. You will get around how much? So this is 10, 21, 7% return minimum you will get, sir. This is what you will get. So you get happy or you get sad or whatever. Based on that, you take a decision. However, the actual way that you should calculate that if it is 100 investment, then what would have been the money in the first year? It should be 1 plus 0.11, right? And the second year, this money gets invested. So basically, in the second year's returns is something like this. And third year, you should get something like this. So then you basically invested $100 or whatever, and you got this amount of money after 3 time period. Smita, yes?
Sir, are you writing somewhere? Because I'm not able to see it.
Can you guys see my whiteboard?
I
Yes,
can
sir.
see.
Yes, sir.
Yes, sir.
Okay.
Scroll down.
How
Actually,
many of
it
you?
has to be moved with the mouse. Yeah.
Oh, okay.
Okay. So you just scroll your mouse and you will come down. Okay. So so this is the case. So now the question comes is that what is the return level? So if the average return, if I say is R, then this much will be the net amount of money that you will get after 3 years. And this is what you actually got. So then the R will be, so if I 100 and 100 cancels out, so R will be a geometric mean of 1.11, 0.97 and 1.13 minus 1. So this is basically where the geometric mean, one of many places where geometric mean is used. So we are using a geometric mean to find out the average return. When somebody calculates the average 5 years return or something like that, this is the number that they will give you. So in the 5 years landscape, what is the average year to year return? This value is generally posted. You will see in many many places, which is the let's say money control or something like that, where you compare multiple mutual funds for in 1 year time frame, in 5 year time frame, in 10-year time frame, this particular value is reported. So this is where the geometric mean will be used. Yes.
Sir, credit card also?
Maybe credit card. Credit card, how will they use?
In paying interest rates? By paying interest rates?
Yeah, so you have to give me. So if the interest rates keep on varying over time, then yes.
Okay.
You have to tell me that.
Excuse me, sir. I have just one question.
Yes.
Sir, this is like a compound interest, right?
It's compound interest, yes.
So it's geometric mean of the compound interest minus 1.
No. Geometric mean of the returns minus 1. 1 plus 0.11. The compound interest, the interest is 0.11. Or the return value is whatever you say. That interest value is 0.11. Second year, you did a loss. Sometimes in mutual fund face a loss, right? Second year, you make a loss of 0.03, 3% loss. Third year, again, 13% profit. So 1.11 is not interest rate. 0.11 is the interest rate. That is 11%. 1.11 is your returns.
Right, sir. Okay.
Principal plus interest.
And sorry, but I didn't understood this 100 bracket 1 plus R raised to power 3. What exactly is this and why it's equal to
So that is the year-to-year average rate, average returns for your fund. What is the average yearly return that the fund gives?
Okay.
So often you will see if you let me just if you just let me just 1 minute, okay? I don't know how to stop this whiteboard. Can I stop this whiteboard? And again, this first time I'm using it here. Just 1 minute. Sharing your screen will close the whiteboard for everyone. Do you want to continue? Yes. And then I'm sharing the screen. Can you see the screen? Let's say I will search for some fund, ICICI, mutual fund, I do not know. Money control. Or let's talk about money control top funds. See this value I'm talking about. So top performing funds, if you go to any this thing, they compare multiple different kinds of fund, equity fund, and this fund and that fund. They will compare it, and the comparison will be based on the returns level, not returns percentage. See this value. So 3-month average, 6 months average, 1 year average, and then comes this 2-year average, 5-year average. 5-year average 14% means it's not every year you got and you basically did a arithmetic mean of the 5 years rate outcome and you got that. It is not actually that. It's basically a geometric mean, or you can do the maths like this, that now what was the score 5 years down the line, what was the score, and then you take an average of that. So basically, yeah.
So is this CAGR value?
It's a CAGR value.
Compounded annual growth.
It's a CAGR value, yes. We are calculating CAGR only here. Even what the equation that I have shown just now. This equation is also CAGR only. You see what I did just now. So CAGR is what? Your whatever you got after, if there are 10, let's say 3 years, as I was telling you, if it is 3 years, then CAGR is basically final value minus current value or old value, let's say whatever is the old value, divided by old value to the power 1 by the time period. That's R also. I'm actually telling the same thing. If you do the maths a little bit, you'll find that this equation and these equations are actually telling you the same thing. But if I do not have the final value now, let's say today I'm investing 100 rupees, I do not know what is the final value that I will get, but I have last 3 years return values, then I will use the previous formula to calculate the CAGR. Okay. Any question? So actually, this is not just 1 minute. This is not, this -1 is final value by old value divided by -1, just 1 minute. Yes. this minus 1. Yeah, so that's CAGR, compounded average growth rate. So that and this are same thing. Whatever I wrote here and whatever I am writing here is basically meaning the same thing, because I have cancelled out 100. If I write the final value was what? Final value was 100 into 1.11, 1 minus 0.03, 1 plus 0.13. This was the final value divided by the initial value, which was 100, to the power 1 by 3 minus 1. So exactly the same thing that I wrote at the top is coming here as well. So yes, that's the CAGR value. So I have just shown a application of geometric mean, which generally I have seen the participants do not know. But yes, harmonic mean can also be used. We have done small in our childhood days. We have done this kind of problem. Let's say a flight from Mumbai to New York runs at a speed of 600 kilometers per hour for the first 2 hours or first 30 minutes, and then around 800 kilometers per hour for the next 100, let's say next 4 hours, or I do not know, here to New York, right? So next, let's say 10 hours, and then at a speed of 500 kilometers per hour again for the next 2-3 hours. Now I'm asking you, what is the average speed, or in how much time it will reach? So if this kind of question comes up where distance and time are used for mathematics, and you will be trying to find out the total time that is required. So total time that is required is basically the you will see the distance divided by the speed that we are talking about. We'll use harmonic mean in this kind of situations. So I will not spend time on it. We very rarely use harmonic mean. In our real life situation, we will not be using, but for these distance time kind of problems, it is used. Now, next thing that comes into this picture is called the dispersion. So what is dispersion? Dispersion is basically talking about how a data set is scattered around its central tendency. That's dispersion. So how the overall data set that you are getting, the population that you are getting, that is scattered around the central tendency. So there's different kinds of dispersion measures as well. So first is range. So we discussed this range at the very first. Here, if you see at the very top, when I was talking about range between 10 to 30 lakhs or between 25 to 40, Gaurav was answering that. So that is when we were actually talking about range. So range is basically defined by the lower limit to the upper limit, or the lowest value in the dataset's context, not lower limit. I would rather write lowest value to the highest value in the dataset. That's your range. It's a measure of dispersion. Another very common measure of dispersion is standard deviation, and etc. We'll talk about that. Let's say I have one data set which has these observations: 2, 4, 6, 8, 10. What is the mean of them? 6. Now I find out each of these observations, how distant they are from the mean. So I get -4, -2, 0, 2, 4. If you add this up, it comes to be 0. Why? Because we all know the positive and negative cancels out each other. That's why we should not add the error. This is called error. We should not add the error. We should do something else. Now there are two choice comes up when this -4 and +4 cancels out, and 2 and -2 cancels out. What will I do to not make them cancel them out?
square them.
I will square them. Why will I square them?
You make
Can I do something else? Why don't I take a mod? Why can't I do it like this? This is 42024. The summation of the mod sign is basically 12. 4 plus 2, 4 plus 2. So 12. So then the mean absolute error is basically 12 by 5, which is 2.4. Now you suggested, sir, no, square it up. So I'm squaring it up also. So the summation of the squaring it up is 40. Then what should I do? This squaring it up, I will take a mean because 5 observations are there. So the mean square error is basically 40 divided by 5, which is 8. And because I've squared it up, because let's say these are 2, 4, 6, 8, 10 was your income, lakhs per annum. Then after squaring it up, it becomes lakhs per annum square. So to bring it back to lakhs per annum again, I have to take a square root. So I take a root mean square error, which is square root of 8, which is 2 into 1.414, so 2.828, something like that. My question towards you is, this is called variance. This is called standard deviation. You know all this stuff, most of you. My question is that which one is a better? So you answered me mean and median. Median is a better when things are skewed. My question is which one is a better measure of deviance and why? Okay, let me pick somebody up. Okay, so you can raise your hand. I'm not picking up anybody. Anybody who knows it? That why should I not take a mod? Why have to take a square it up and then take a mean of that and then take a square root? 3 more activities. Rather, I will take a mod and get the value. Yes, Suman.
Sir, hello.
Yes.
Okay, sir. Actually, if we take the mean of the deviation without squaring the same, then again the data could be somewhat sinusoidal data, and we could have find out the deviation as 0, and it won't make sense because if we are making the observation or if we are making the inference from that. Sir.
Why it will be 0? I'm taking a mod. Why even if the data is sinusoidal data, and I'm trying to find out the error, after taking mod, everything is positive, right?
Yeah, but again, sir, if there are some like we are penalizing the outliers more, sir, like in the root mean square, in the RMSE method, we are penalizing the outliers.
Can you elaborate what do you mean by penalizing the outliers?
Sir, because this I can understand because the more the distance from that line or the line which we are trying to build, correlation line or any line, then again it will be more penalized if it is square it as compared to the mode.
Yes, my question is that means this is a textbook term that you told me just now. Do you understand what do you mean by penalizing? And in what activity exactly we are penalizing?
So like the point is if we try to analyze like 10,000 series of data, and if there are some outliers, and if we are trying to make a predictive model out of that, then we will try to remove those points which are quite
no, that is fine. That is outlier removing of outlier. Yes. That's a different exercise that we'll do later. So I am not saying that we should take it. I'm just saying that yes, so outliers create problem. I'm saying that asking you how RMSE helps you in identifying and removing them, and which MAE, mean absolute error, cannot do. Or no? Raising your
Squaring
hand.
and then routing that portion.
Squaring and then rooting. Just understand this, all of you. So you have done this before. I'm pretty sure that you have an idea about RMSE. But you see here, this guy is 2 points away from the mean. And this guy is 4 points away from the mean. This is basically the mean. It's a sinusoidal data that he was trying to say. It was not exactly sinusoidal, and more or less. So -2 and -4. These two guys' contribution towards this error is at a range of 4:2 or 2:1. But the moment I calculate MSE, it is at the range of 16:4, which is 4:1. By saying that, what I'm trying to say, that in this 40 value, this guy, which is the observation 1, is contributing much, much more than what it was doing in this particular calculation value. Why? Because I am squaring it up. I am amplifying. The more I square, I amplify problems. So I'm amplifying it, and then I'm taking this mean. However, there is a catch. This may not work. This amplification may not work if the data is between 0 and 1. In such kind of situation, mean absolute error plays better role, because as you know, squaring up creates an amplification only when the variable is higher than 1, right? The value is higher than 1. Then only squaring up will amplify. But if the data was between 0 and 1, 2, 4, 6, 8, 10, instead of that, if it was 0.2, 0.4, 0.6, 0.8, 0.10, my RMSE score would not amplify. Here you will see that your mean absolute error is lower than this RMSE score. So RMSE, the standard deviation, is a more conservative way of seeing the things. So anything which is a little bit higher scattered, Suman was telling penalizing, we will penalize it, and I will show big deviance score. I will say that, okay, this guy is very, very away, because what I'm doing is basically his distance, I'm squaring it up. But that all of those things make sense as long as the data is higher than 1. The numeric variable can be anything higher than 1. If the data is not higher than 1, if the data is bounded between 0 and 1, we should, in those kind of situations, probably MAE is a better way of measuring. So in later point of time, when we do machine learning problems, you will see that oftentimes we normalize our data before we do machine learning. Normalize means convert the variables between 0 and 1. However, in the case of econometric problems, regressions and etc., those who are understanding these lines now understand. I will again be more thorough later. Those who are understanding, those have an idea about, those who are working already with data, probably for them at least they should probably try to think a little bit over the next couple of days, that if, and that's why what we do is that in the case of econometric models, we do not normalize, we standardize the model, we standardize the variables. Means we convert it to such a form such that the mean is 0 and standard deviation is 1. But the individual values of the variable can be anything between, let's say, 3, 4, 5, -3, -4, -5, something like that. That's possible. But when I normalize the data, everything becomes between 0 and 1, which is generally used in machine learning problems. And so in machine learning problems, it has been seen that mean absolute error is a better choice of model fit or this and that than RMSE. So this small discussion that I wanted to do. However, people who are new in this line, you don't have to worry right now. You just know that there are two different kinds of error that is there. Standard deviation, never try to mug up the formula. Standard deviation means this thing you mug up: root mean square error. It is very easy to write the formula if you remember. What is error? Error is individual observations minus mean. You square it up. Then you take a mean. How to take a mean? First you sum it up and then you divide by number of observations. Then you take a root. Okay. So this is our formula for standard deviation. Don't try to remember it. The more you try to internalize this kind of things, the better. So root mean square error is something like this, which is also named as standard deviation, which is used in case of numeric data to find out the deviance, the dispersion of the data, how they are scattered around. There are other way of finding out the the dispersion. There's another way, which is a non-parametric way. Let me tell you what that is. Let's say I have a data which is 1, 3, 5, 5, 7, 7, 9, 9, 10, 11, 12, 12, 12, 13, 13, 15, 16, 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 data points are there. Let's make it 19. Can you tell me what is the median of this data?
So if there are 19 observation, then the median would be 10.
10th observation, which is also
Yeah,
10,
10th observation. Right, right.
which is median. So this is my median. So if this is my median, this is also the middle number. So this is also my 50 percentile. What is the percentile? Anybody? What do you mean by percentile?
Below which 50% of the population resides.
Below which 50% or below or equal to which 50% of the population resides. So that is my percentile. So it's not that, so this is very important. This particular word, what he told is absolutely right and very important to understand. I'm pretty sure again, almost half of this class, this is my overall observation from the past, the half of the class does not understand percentile. So out of all the observations that you see, 50% will be below this value. So that I can see here as well. So then can anybody tell me what is the 25th percentile here in this data?
I think 5.
Yes, sir, 5. The 5th observation.
Why?
So because below that, 25 percentile.
So 19, 25, 19 observations are there. 25% of 19 is how much? 4.8.
4.25. 4.2.
4. What? 4.45 or what? What we're saying?
4.25.
4.25. Okay. So 4.25 number of observations has to be lower than a value. So these values lower than this value, there is no observation. So that this is not median. Lower than this value, there is only one observation. So up to this is 2 observations. This is not median. Up to this, there are 3 observations. This is not median. Up to this, there are 4 observations, not median. Up to this, there are 5 observations. That means 4.25 observations are below it. So if you actually try to find out very specifically, it will be weighted average of these two number, with this giving 0.25 weightage, sorry, 0.75 weightage, and this giving 0.25 weightage. However, so you can do it like this, like this is 4, this is 5th. So 4.25 is somewhere middle, somewhere in middle of that. So weighted average of these two. However, an easy way of doing it rather than exactly is choosing the 5th number. which is below that, basically 4.25 also falls. So rather than not going into that detail of finding out the weighted average, we can choose the fifth number. So the fifth number is 5, which is also can be done in this way, that this is my lower half, and what is the median of my lower half? That is my 25 percentile. 25 percentile is also known as lower quartile or first quartile. Why quartile? That means 1/4 is lower than this. So this is called second quartile. That means 2/4 are lower than this. Then what number is the third quartile or upper quartile? Basically median of this 1, 2, 3, 4, 5, 13. So this is my upper quartile or third quartile. And one way of defining standard deviation or sorry, dispersion is this interquartile range. This is also named as Q1. This is also named as Q2. This is also named as Q3. So IQR, interquartile range, is Q3 minus Q1. This is also often used as a measurement of dispersion, more so when the data is skewed. When mean and standard deviation cannot be used, sometimes we use this. Now, why we use this? There is a term somebody used called outlier. We also use certain term called outlier in this particular context, using the mean and standard deviation or using the median and interquartile range. We can define outliers. Outliers means something which is not exactly in sync with the data. So any observation which is outside of the following range can be told as outlier. And you can remove them from the data set or you can handle them separately. So one is mean plus minus 3 standard deviation. Y3 will answer it by the end of the class probably. Or median plus minus how much? 1.5 interquartile range. So this is the limit up below, above which or beyond which we say that this is an outlier. So there are different ways to identify outlier. One is by plotting a box plot. So what is box plot? Gaurav will show you in the next class when he does work with graphics. If not next to next, I will give you one extra session to Gaurav probably, which is an additional session where we'll talk about graphics. So in that particular class, box plot will be plotted and you will know. So, or you can do this exercise. You can run a if-else function and check that whether the observations are within this range or outside that range. So that is called outlier. I will stop here. If you have any questions up to this point, please let me know.
Sir, can you please let us know another time why is this mu plus minus 3 median standard deviation is taken as standard for the outliers?
Okay, so I have not answered it. I will answer it later. That's what I told.
Okay.
Okay, I will come back to this. So Y3, I will come back to this. I'm not answered it yet. Right now, you just take it as a means Guru Vakka or something like that. In another 1 hour, you will know Y3. You can see the whole this thing now if you scroll up and scroll down. So
Yes,
like,
Yes, sir.
right now I'm scrolling up and scrolling down. Can you see that?
no, we have
No,
to
sir.
call
Okay,
ourselves.
okay. So that means that if I have to refer something that I wrote at the back, then I have to tell you to scroll up on your own.
Yes, sir.
Yes.
Is it not? Okay. I'm also not sure whether what is exactly getting recorded. Is my writing getting recorded? Anybody who has used whiteboard before uh, in Zoom in the class?
Yes, sir. It gets recorded as per the host screen.
Okay, okay. Then it's fine. Okay, fair enough. So next we will go ahead with the next step, which is probability. So we talked about a little bit of statistics. Let's talk about a little bit of probability in the next half an hour, and then we'll take a break. So what is probability? So we know probability is basically chance of happening something. For example, let's say in this urn, let's say there are 4 this kind of balls, white balls, and there are 3 striped, 5 striped balls, let's say. So what is the probability if I blindly select some of the ball will be a striped ball?
5/9.
The number of strike ball by the total number of balls.
Yes, so the number of striped balls by the total number of balls. So so not this, sorry, the total number of balls. That's basically the probability. Now let's talk about something called a Venn diagram. We sometimes also express this particular thing using a Venn diagram, and we say that, okay, let's say these are all the striped balls and there are 5 such observations, and anything outside that is non-striped ball and there are 4 such observations, and the whole box is basically 1. That is the all possible values. So then if this is called the striped balls and this is called the non-striped balls, and probability of striped balls plus probability of non-striped balls is 1. So something like this. Now let's assume something. There are certain people which are like this also. So there are men and women and they wear spectacles or not wear spectacles. Let's say there are 12 men and there are total 20 people who wear spectacles, and out of 25 people, and out of that 5 are men wearing spectacle and 12 are men not wearing spectacle. And there are 20 people here, and there are, let's say, around 7 people here. So the first one is men and this is spectacle. Now the question that I'm asking you is this: what is the probability that if I blindly choose somebody from this particular group, the person chosen will be male and wearing spectacle? Oh, sorry, not and. I will write. Okay, let's first write and wearing spectacle. What is the probability? That is number of persons who are men not mean. I hope not. Mean
39.
and spectacle by the total number of observations, which is basically 5 by 39. Somebody told, right? 70, 30, no, not 39. 44, right?
Yes, sir, 44.
5 by 44. Now, if I ask you the same thing and say that what is the probability that the person will be man or wearing spectacle? Now you see, what are the possible options? He can be a man and wearing a spectacle. He can be a man and not wearing a spectacle. He can be a woman and wearing a spectacle. So these are the three options that is available. So let's write it down. So then what is the probability that a person is a man or wearing spectacle? How do I write that? That is probability of M and S, or we can also write it like, sorry, not and or S. We can also write it like this, union S. Now, what are these things? So, first of all, man wearing a spectacle and man not wearing a spectacle. That means total man. So, probability of man, or rather, let's, before jumping into the probability, let's write it like this way. So, this is number of persons M greater than S divided by capital number of person, and now this number of persons I break. So he can be either man or wearing woman not wearing a spectacle. So who are the women not wearing a spectacle? There are some women minus there are some women wearing spectacle. That is the number of women who are not wearing spectacle. That divided by capital N. So if I do that, what I get is P of M plus P of W minus P of W and S. So basically P of M plus P of W minus P of W intersection S. So we know this, I've just quickly derived. So that in other words means that P of A given B, A union B, is P of A plus P of B minus P of A intersection B. So this is a formula that we know, but this is something that we will be using in our data science, data analytics quite a bit. So P of A union B is P of A plus P of B minus P intersection B. In the Venn diagrams context, when I say main or wearing spectacle, I'm actually talking about this area, this shaded area. And this shaded area is basically a summation of this whole area and then okay, so what did I write? Just 1 minute. So this is not W, just 1 minute, this is S. This not this S. So because this will not be woman and not wearing spectacle, this will be woman and wearing spectacle. Yeah, woman and wearing spectacle. Yes. Yeah. So this is P of M and S, and this will be just 1 minute. I've written it wrong. This will be M and S. Why I'm choosing? That's how this formula is coming. So this area, which is this shaded area, plus the added shaded area, which is again this one. And one part is coming common in both of them, which is being taken twice. So I will be basically leaving it out. And that's how this formula is coming. Now, if I move ahead a little bit more. So I talked about P of A intersection B. And whatever I have drawn here, let me draw it once more. So there are total, if you see, 12 plus 5, 17 men, and 20 plus 7, 27 women. So in the whole data set, out of 44 people, there were 17 men and 27 female. And out of this 17 male, there were 5 people who were wearing spectacle, and no spectacle was 12 people. And out of this 27 female, there were 7 people who were not wearing spectacle, and 20 were wearing spectacle. Now, if I ask you that what is the probability that a person is wearing a spectacle given that the person is a man? If this is the question that I asked, then what is I'm asking? I'm asking number of persons. It is given that this person is man. So he will be man, but he is also wearing spectacles. So number of persons who are wearing spectacles and man divided by the total number of persons. Now, total number of persons, will I take all 44? No. Because why? Because it is given that this person is man. So what is non-stochastic in this whole thing is his being a man. The person is a man. This is non-stochastic. It is fixed. What is stochastic is whether he is wearing a spectacle or not. Whether he is wearing a spectacle or not, that is probabilistic still now. That is not fixed till now. So he is man, that is fixed. That's why the total number of persons that is coming up here is the number of man. And in the numerator, what will come is number of persons with spectacles and man. Now, if I divide it with the total number of persons at the top and the bottom, both, what I get, it probability of spectacles and man divided by the probability of man. So if I just write the same thing in the mathematical term, what I say is that probability of A given B is probability of A and B, or A intersection B, by probability of B. This is a very common this thing used in our very common formula used in our data science, which is called
Bayes theorem.
Bayes theorem. Now this can also be written in a different way. Let's derive a few stuff from here. So if I can write pay, can I write it like this? Can I write it like this? Yes. So you also know that A and B and A, they're the same thing. So you and I and you is the same thing. The group is same. So if I just replaced B with A and A with B, I can write it in the same way like this. So I've just changed the position of B and A, and I can see that. Now, if the left hand sides are same, just now I told that these are same. So LHS is same, then RHS will also be same. If these two are equal to each other, then these two will also be equal to each other. So then what I get from that is P of A given B into P of B is equal to P of B given A into P of A. Or what I get is P of A given B is P of B given A into PA divided by PB. This formula is more used in Bayes theorem for all the Bayesian statistics that we try to do. Will not do in this course, but probably in a different course or different when you learn data analytics, you will also try to do Bayesian statistics. This particular form is used more. This is also Bayes theorem, just I'm writing it in a different way. That P of A given B is P of B given A into PA divided by PB. You can do maths on that. I will give you some sample problems, and those who are from our institute, they will know that we all study this statistics books. In any statistic book, you will find problems on this kind of topics. Now, let me do one more step, and I'm pretty sure you do not know this thing. You know the final result, but you don't know. So let's say, what is the probability that you will have a good night's sleep today given that, let's say, given that whatever, what will I say? Given that 30 airplanes took off today from Kolkata airport from, let's say, 2 p.m. to 6 p.m. or 5 p.m. Can we answer this question? What is the probability that you will have a good night's sleep today, given that 30 airplanes took off today, double F, from Kolkata airport from 2 p.m. to 5 p.m. Let's say in general, you have a good night's sleep at a probability of small p. Let's say in general, your probability of good night's sleep is 0.98. Means out of 100 days, 98 days you have a good night's sleep. 2 days sometimes, because of whatever reasons, you don't get to sleep. Can you answer this? What I'm asking basically, can you express this in a mathematical form? Angela?
Yes, sir. Sir, probability of good night's sleep given the flight taking off.
Flights taking off is 30. Flights taking off is equal to 30, let's say. This is what I'm asking you. So how to answer this? How much will be the value? Forget about the maths. What should be the value? Can you tell me? And you are based out of not Calcutta or not near Dum or anywhere. You are, let's say, based out of Mumbai. What will be this value?
In that case, the probability should be 1 because I will have a
Why it should be? Why will be 1? Why not? Why it will all of a sudden go up? In general, you have a 98% chance of
sorry, sir, 0.98, 0.98.
0.98, right? It will not change. It will still remain 0.98 only because these two events are not related to each other. So in other words, what you are saying using your common sense is that if two events are not related to each other, then one event's occurrence does not impact the probability of the other event's occurrence, right? The probability of the other event's occurrence. In other words, what I'm saying that if A and B are not related or independent, then I'm saying that P of P given A and P of B, or let's say not, let's write A given B. P of A given B and P of A are same thing. So whether B occurs or not, A has nothing to do with it. Now I will use this in this formula. In Bayes theorem, we have wrote this. P of A union B is this. Let's write it down. Sorry. So from Bayes theorem, what do I get? From Bayes theorem, I get that P of A given B is P of A intersection B is P of A given B into PB. This is what I got from Bayes theorem. Earlier, I have written it at the top. Now you are saying that if A and B are independent, then I can replace it like this. So then P of A intersection B, I replace it with P of A, and that gives me P of B. So this you know, but this is derived from Bayes theorem. So it's a special case of Bayes theorem. This is a general case. For all general case, this will happen. But if A and B are independent, this will happen. So we very easily use this. This P of A intersection B is P of A into P of B. We do not know the derivation. Most of we do not know the derivation. So this is a basic derivation behind it, that why East happens. Fair enough. Any question up to this point? So these are some of the basic statistics and probability rules we have studied in the past. I'm just giving a recap. Next 15 minutes, I will talk about something called probability distribution. So after this next 15 minutes, we will take a break. And after another 15 minutes of break, we will talk about some specific probability distributions. We'll try to cover 3 distributions. One is binomial, Poisson, and normal distribution. So this knowledge will be required to do the further activities, which is t-test, f-test, as we go ahead in the next week's course. So for this week, we'll cover up to normal distribution, and that's where we'll stop. So let's talk about probability distribution. We talked about up to this point what is probability, and we have done some formulation of probability. You can do some maths. I can share some maths activities how to calculate probability. But that's basic. That's something which is more like a 10th standard, 12th standard maths that we do. Now I will talk about probability distribution. What is that distribution? Probability distribution is basically, it can be a graphical representation, it can be a textual representation, it can be a formula wise representation. Whatever way you are representing a probability of all the possible outcomes or all the possible realizations of a random variable. Okay, so I have told quite a few terms. Let's step by step understand that. The moment we talk about probability distribution, one term comes up which is called a random variable. What is a random variable? A random variable is a variable which can take any value. It's like Schrodinger's cat. Have you heard the story of Schrodinger's cat? Anybody in this class?
Yes, sir.
Yes. Vishwas, what is that?
Sir, it can have two different states. So if you, it goes as a famous experiment that he did. He put his cat and a bowl of milk with poison in a box.
Yes.
Until he opened the box, he is not sure if the cat is alive or dead, because you have to open the box, and then so till the box is opened, there are two states possible. One is the cat is alive, another is cat is dead.
Yes. So the current state of the cat is both alive and dead. That's why, with certain probabilities. That is called a random variable. That Schrodinger's cat is called a random variable. So you do not know until you open the box. Till that point, it's a random variable. It can have anything. It can have any value. And you probably, in that particular case, he does not even know the probability distribution also. What is the probability that the cat is alive or dead? Then he could have calculated many things. But at that point, he was not even sure that what is the probability distribution. So in this particular case, random variable means a variable whose value you do not know. What do you know? You know the possible realizations. For example, let's say a random variable can be the income of the next person who joins this particular class. So the next person who joins the particular class, I do not know who he is, he or she is, so I do not know what is the income of that person also. So that is a random variable. It's a possible, what are the possible realization? Anything between 0 lakhs per annum to, let's say, infinite lakhs per annum. Anything can be the possible distribution. But let's say the gender. If I say that what is the gender of the next person, then probably I have 3 choices: male, female, others. I do not have any other choices. So that is the possible realizations. Also, so probability distribution of a random variable, what it will give, it will represent in whatever way, in graphical way, in functional way, whatever way, it will represent the probability of all possible realizations of a random variable. Now, how that can be written? Let's say I write that the next person who will raise a hand in this class, if I believe that everybody has an equal probability to raise their hand, then, and I know that the other gender is not there in this class at this moment. So let's say I represent it like this, that there are 0.7 probability versus 0.3 probability. This is gender. This is probability of raising hand. This particular picture is a probability distribution. Let's say I say, instead of writing like this, I say that probability of capital X is equal to small x. This value is 0.7 when small x is male, and is equal to 0.3 otherwise, or I can say point when small x is equal to f. This is also a probability distribution. X is raising hand. Gender of the person raising hand. So gender of the person raising hand, I don't know till he raises or she raises the hand, but this is the distribution. Now probability distribution has lots of usage. Probability distribution are used to calculate the mean values oftentimes. For example, let's say if I say that there are this probability distribution, and let's say there are male income, or let's say men's age in this class, the average is of 24 years, and female's age is in the average of 22 years, let's assume, and the weightage is, let's say, probability distribution, as I told, was, let's say, 0.7 and 0.3. Then what is the mean age? What is the expected age of a person in this class? So the expected age why it is not coming up? What happened? Just 1 minute. Can you see things getting vanished? I'm writing some stuff and it is getting vanished. I don't know why.
Remove me as co-host. Sorry.
Come again?
Remove me as co-host. I can also see the cursor. This cursor is also used by me. I can also use this whiteboard.
But you cannot see something being written, right?
Yeah, I can see. I can also see which are writing. After this sigma, nothing I can see. Male, female, nothing after that.
Nothing
Sir,
after that. No?
Summation is coming up.
Come again?
Only summation is being shown.
Okay.
Now it's gone.
I just removed the summation. Just 1 minute. How will I stop sharing? Just 1 minute. Huh? Just give me 1 minute. Yes, I'm trying, William. Before that, I want to just share it. Sorry, save it. So export in PDF.
So this export, it will only show this current image, not the entire one.
No, so if I export as PDF, oh, then also it will just do it for the current image.
Yeah, for current image only it is doing.
So how will I export the whole thing? No way.
You can zoom out and do it in zoom out.
That is a bad idea.
Very long page.
Is there a way to come up with new pages? Okay, let me just quickly do it then. Just 1 minute.
Just use the number 1 at the sidebar, the last pages. You click on that, you create a new page. On the sidebar, the last icon.
Yes, in the sidebar, the last icon. Okay.
Yeah, pages, number 1, it shows a 1.
Okay, okay.
You click and you create a new page. Up to 12 pages you can create.
Okay, okay, got it.
Yeah.
Got it. Let me just take a export of this. And how to save the whiteboard? If I want to save it as PDF or something like that, export will take only the snap, right? Anyway, so Gaurav, you can scroll up and scroll down, right?
Yes, sir. Yes, sir. I will download. I'm downloading.
Gaurav, yeah, please take a download of the whole thing, okay?
Yes, sir.
So you just quickly scroll down and take pictures of multiple pages and then make a PDF out of it.
Yes.
Okay, I cannot write it. Okay, now no, the writing is not happening. And let me know once you are done, then I will come up with a new page.
I'm done, sir.
Okay, let's start with a new page then. So let me just see that whether writing is, yeah, it's happening here. Okay, so where were we? I was discussing about probability distributions. Okay, so now there are probability distributions, as I was telling that we can, I will take a few minutes and then I will take a break and then I will start again. So as I was telling, that probability distribution can be used to calculate the mean. So if you are, if you remember, I told that there will be 24 years and 22 years, 0.7 and 0.3. That's what I told. So if the men are of 24 years in average with 0.7, and female are 22 years in average with 0.3, then the expected age of this batch, which is also written as E of X. X is the age, which is the random variable. E of X can be written as, or no, new page is not visible.
No, sir, I can
No,
see the
sir.
old page only.
Yeah, we can see the old page on the.
Okay, you will also have a left side scroll button or something like that.
Yeah,
Okay,
now we
okay,
can
okay.
see.
Got it,
We
sir.
need to select
Yes,
the
yes,
two.
yes.
Yeah, sir.
We have to click on that page.
Yes. So in the second page, so what I am writing then is expected of X is basically the individual X size and probability of X size. So individual X size is what? 24 years in one. What is the probability of that occurring? 0.7 plus individual years is what? 22. And what is the probability of that occurring? 0.3. So you calculate the value. So this probability distribution, at least this part, which is the probability distribution, helps you to calculate the expected value. Expected value can also be told as the mean value. This is also the mean age of the batch. Why this is the mean age of the batch? You see, if there are 10 people in the batch by any chance, and their average, I'm saying that then there are 7 male and 3 female, and the 7 males average age is 24 and 3 females average age is 22. So what is the total age of the main? Total age of the main is 24 into 7. And what is the total age of the female? Total age of the female is 22 into 3. So then what is the total age of the batch? Total age of the batch is 24 into 7 plus 22 into 3. So then what is the average age of the batch? Average age is this divided by 10, which is the same calculation that I did at the top, 24 into 0.7 plus 22 into 0.3. So the expected value and the mean value, the same thing. As long as you know the probability distribution and individual observations, you can calculate the average using the probability distribution. Now, many further usage of probability distribution, like variance, standard deviation, can also be calculated in the same way. I will not go into this detail right now, but we will talk about 3 specific probability distributions after the break. 2 of them will be discrete distribution, means where the X variable, the random variable, is a categorical variable. And in one of them, the random variable is a continuous variable. And these 3 will be used in data analytics as we go ahead quite a bit. And we have to keep them in mind. So with that, I will stop this session and I will come back. Let's say right now it's 5:25. By 5:40, we'll come back and we'll take 1 hour session after that. So we may require one extra session probably from my side also. So on 14th, we will keep 2 hours of session, 1 hour from Gaurav and 1 hour from me. If anything that we know that that the things are getting delayed and we are, for example, this technical difficulty which I am facing right now, where I wasted 10 minutes. So I might require just 10-15 minutes, or you might require to ask some question to me. So we'll have 2 more hours extra on 14th, and probably in the evening, probably after 7 p.m. We'll discuss on that particular day. I am busy up to 5 p.m. on 14th, so I cannot take before 5 p.m. After 5 p.m. it is possible. So 5 to 6 probably Gaurav can take, and 6 to 7 I will take, and that's how we'll basically wrap it up. Anything that is left out, any questions that you have from this kind of sessions, we can ask on that day. So we'll take a break now, and I will come back at 5:40.